what are sequences? Well, you know what sequences are. Let me just write down one of them. Okay, so here's a simple sequence. So 2, and then 5, and 8, and 11. And I'll put dot, dot, dot. Incidentally, the dot, 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 ellipsis, okay, it means that this pattern continues indefinitely, okay, forever, in other words, okay. It's our job to analyse, see what's going on with the sequence, okay. It is a pattern, and we're interested in what the pattern is, what the rule actually is for the sequence, okay. Now, hopefully you can tell me that the sequences are going up in threes, okay, so I'll just put there from this term to this term, from this term to this term, and from this term to this term, we're adding 3. That is what we call a common difference, okay? I'm going to write letter D there, because that's going to come up later on, okay? The D stands for the common difference between each of these terms. That helps us to find an expression for what we call the nth term, okay? The nth term is a generic term that lies somewhere in the sequence. So this is term 1, term 2, term 3, term 4. What is the 50th term? The 100th term? The nth term. Okay, hopefully you get an idea of what we mean by that. The pattern is that because we're adding 3 to each term, that means it's got something to do with the 3 times table. Okay, so we could write down 3n as in the 3 times table. Okay, that's our expression for the 3 times table. When n is 1, n is 2, n is 3, you get 3, 6, 9, and so on. Now if we subtract 1, okay, from the 3 times table, we will get 2, 5, 8, 11. I'm sure you agree with me. The 3 times table, 3, 6, 9, 12. Subtract 1 from each of those, you get 2, 5, 8, 11. This is what we call an expression for the nth term of this sequence. Okay, it's 3n minus 1. And it's as simple as that. Okay, you find what the common difference is, and then you add or subtract as appropriate from that particular times table. I'm hoping that made sense. So suppose you want to, as I suggested, work out what the 50th term is. You just put in 50 into that. 30 multiplied by 50, subtract 1. Okay, and that is going to be 149, isn't it? 149. So that's an example of a simple sequence. Okay, let me give you another one. Board rubber. Okay. Let me give you another one. Maybe I'll just keep that one there for the time being. And I'll just write down the nth term as 3n minus 1. Okay, so here's another one. So we'll start with 7, and then I'm going to give you 12, and 17, 22, 27, etc. Dot, dot, dot. Okay, the dot, dot, dot is important, otherwise, if it's not there, then I'm saying that that term is the last term. So I'm saying 1, 2, 3, 4, 5, I'm saying it's a 5-term sequence only. So the dot, dot, dot means it continues indefinitely. Okay. So what's going on here? Well, you can see the common difference is 5 in each case. 5, 5. So that leads us to deduce it must be something to do with the 5 times table. So 5n. What is the 5 times table? It is 5, 10, 15, 20, 25, etc. I'm sure you can see if you add on 2 to the 5 times table, you get 5n plus 2. Okay. And it's as simple as that, really. Okay, it's as simple as that. These are what we call linear sequences. Okay, linear because the nth term is linear. Okay, quadratic sequences are slightly harder. Let me show you an example of a quadratic sequence. Yeah, the only thing about this board is when I feel like I've got to hug it to flip more, stop it shaking. It's so annoying. Yeah, it does rattle a bit when I clean, doesn't it? Let's give you an example of a quadratic sequence. Okay, so I'm going to try and give you a simple one. Okay. Do you know what the nth term is? Some of you are thinking yes, some of you are like, no. Well, what is a quadratic sequence? Okay. If you start by looking at the common difference between each of these, there's a contradiction in terms there, aren't there? Because there is no common difference. Okay, here. So what we'll do is we'll look to see if there's a common difference between these. Okay, this is what we call the first differences. And I'll write down what the second differences are. the differences between these, and it's going to be 2, 2, 2. Those are common. Okay, because we've got down to the second difference for it to be common, as in the same throughout, then that tells us it's a quadratic. Okay, your next question might be, what does that mean if you go down to the third difference and then only then is it going to be common throughout? Is it a cubic? Then yes, you're absolutely right. Okay, and so on. Okay, but in our syllabus we never ever go further than a quadratic. Okay, so that's a quadratic. Okay, now I'm going to give it to you as a rule. I'm not giving you as a proof. Okay, but the rule is whatever this second common difference is, you halve that, and it gives you the coefficient of n squared. Because it's a second difference, it's a quadratic sequence. That means the form is going to have something to do with n squared. There's sometimes a coefficient other than 1, like 2n squared, 3n squared, half n squared. There's sometimes a coefficient other than 1 in front of that. To work out that coefficient, you always halve that number. Why does that work? Look it up if you want. Google it, find a YouTube. I'm not about to go through a mathematical proof because that's not what we're doing today. Okay, but it's a method that will help you. It will work. Okay, so half that means 1n squared. Now if you then write down what the squared numbers are, 1, 4, 9, 16, 25, and compare that with the original sequence, you see, 1, then 2, 4, then 5, 9, then 10, 16, 17, we add on 1 to each of those, don't we? Okay, so that makes us conclude that n squared plus 1 is the nth term for this sequence here. Okay, you can always check that by substituting the value in. For example, if you want to check that indeed the fifth term is that, you substitute n equals 5 and you get 5 squared plus 1, 26, which is indeed that. Okay, happy? Hope so. I'm going to do another one. Bear with me because I didn't come prepared with notes, so I'm just making these examples up as I go along. Kind of like I do in class. Make it up as I go along. Yeah, so I'm going to give you another sequence, okay? So I'm just going to start off with a random number. I'm going to start off with 2. It's as good a random number as any, okay? Now just bear with me, I'm just going to think of a suitable sequence, okay? So, let's just try this, see what happens. So 6, 14, 26, 42, that'll do. Okay. Maybe pause the video and just try and see what's going on. Unpaused, great. So the first thing you should look at is the first set of differences. So that's 4, and then that's going to be plus 8, that's going to be plus 12, and that's going to be plus 16. That's the first set of differences. Check to see if they're common. No. So you look at the second differences, and you'll hope that they're common. Okay. So second, that's 4. It's 4, 4. Great. That means the second differences are all common. Okay. That means if you've had to go down to the second difference, that the expression for the nth term is going to be a quadratic. Okay, something n squared. Remember the rule I told you? Whatever that second common difference is, you halve it. Half of 4 is 2. So that tells you that it's 2n squared. Our job is now to work out what the rest of it is. What we do is we write down what the terms are for 2n squared. That means double the square numbers. Okay, remember the square numbers? 1, 4, 9, 16, 25. If we double the square numbers, we get 2. And then 4 times 8. And then 9 times 2, 18. And 4, 9, 16, that's 32. 50. Okay, so 1, 4, 9, 16, 25. Double those, okay? And then what we do is we work out what the rest of the sequence is. I'll design a tricky one for you on purpose. But if you understand this, you'll understand how to do any of them. Okay, that's my thinking here. We work out what the rest of the sequence is from this to this. Why are we doing that? Because 2n squared is what this is so far. We've got to work out what else we need to get this, hence the rest of the sequence. Okay, so 2 plus 0 gives us 2. 8 subtract 2 gives us 6. 18 subtract 4 gives us 14. 32 subtract 6 gives us 26. And 50 subtract 8 gives us 50. Can you see how that works? Okay, so if we did 2 plus 0, 8 subtract 2, 18 subtract 4, 32 subtract 6, 50 subtract 8, we get to this. Okay, we now find the nth term for this. Okay, so we work out the common difference. This time, because they're going down in twos, we put the common difference is -2. Okay, -2. What that means is it's something to do with the -2 times table. Therefore, the sequence will be something to do with -2n. Okay, the -2 times table is -2, -4. Let me just write down: -2, -4, -6, -8, -10. What do we do to the -2 times table to get these? Well, we add on 2 to each one. Okay, just check: -2 plus 2, -4 plus 2, -6 plus 2, -8 plus 2, -10 plus 2. Okay, I'm going to rub that a little bit off. And then we just combine it all together. Our formula for the nth term of this sequence must be that plus that. Okay, so I'm going to write down, therefore, we're going to have 2n squared and then subtract 2n plus 2. And that is it. You can just check by putting a value in. Let's just try the fifth term, shall we? So when n equals 5, you're going to have 2n squared, so 5 squared is 25 times by 2, that's 50. Subtract 2 times 5, so subtract 10 plus 2, look at that, 50, subtract 10 is 40, plus 2, 42, and then just check, there you go. Okay. Frankly, you're not going to get anything harder than that in terms of a quadratic sequence, so if it pleases you, just re-watch the video again, look, see exactly how it was done, okay, and maybe try and have a go at some examples, okay.